Hello and welcome to another ASMR coding session. You can see that I have an empty Python notebook here, and you can already see that I'm going to be doing a challenge from something called Advent of Code. You can find it at adventofcode.com, and I will link everything down below. And you can also see day 1 to 7 on my channel and on my GitHub, also linked down below. But let's get started with this challenge. Okay, so we have a 7-segment display, and for example here you can see a 0, and there almost every segment is activated except for the dotted line in the middle. But the wires have been crossed, and we have to deduce which wire A to G controls which. Of the display. So A could be G and so on. So this is the original mapping, but they are now a bit messed up. So here's one example input. We get 10 combinations, each of those are a number, and then we get the 4 numbers that we have to translate and find something out. So let's save the example input from the text. So here we have 10 lines, and each of those has 4 numbers in the end, so we get 14 numbers to investigate. So now let's solve part 1. Okay, in the first part, which is a bit easier, we can look at 1, 4, 7 and 8. 1, 4, 7 and 8 are all unique. 1 is the only number where only 2 entries are in. 4 is the only one with 4 segments. 7 is the only one with 3 segments. And 8 is obviously the one where all 7 segments are activated. And then we have some that share properties, like 6 and 0 both have 6 segments. 1 has 2 segments. Okay, let's get to can strip all white space. And now we've seen that each line has format here, so we get a bit of string, a vertical space, and then more string. So let's define another function to use that takes one line and then we split it into the observations and the final outputs. And we split the line at the vertical line. And now the observations will be split at a white space. And the same for the outputs. And then return that. Okay. And now in our function we can just, so for each line we get the observations and outputs by passing the line. Check this for now with our example txt. So we have, for example, this. We see that we get all of these observations, BE, CFB, E, etc. And then we have 4 entries for the thing after the line. So we have extracted everything successfully. So we know that all of these special numbers have special type of segments, number of segments. So we don't even need to look at the content. We already know that BE, this is the only one with 2 entries, with 2 letters. And therefore BE has to encode a 1 in our display, because this is the only one with only 2 activations. So either this is B and this is E, or this is E and this is B, but it doesn't matter. We know that BE means 1. It's basically like learning a new secret language. So we only have to look at the length of the strings. So let's compute the length. And now we can count. So initialize a counter, and then add how many entries have a 2 long entry, and same with the 4. Same with the 3 for the number 7. And the 7 for the number 8. And now we can see What's wrong there? I don't see any difference. Okay. Oh no. So it tells us in the example R26 is also what the website tells us. So now we can check the real puzzle input. Which gives us 362. We checked this on the website and that's correct. So now we can do the more complicated part. Okay, for part 2 we now need to actually deduce all of the numbers, so even the duplicates. So let's see. About the mapping from signals to the observed numbers. And translate the 4-digit outputs at the end of the line and add those numbers across all lines to get the solution. So here I've pasted the original wire names again. On top we have A, B, C, D, E, F, G. And I think I will now build a dictionary. We need to deduce whatever the wires from the observations. Let's create an empty dictionary. And first, identify the observed signals of 1, 4, 7, and 8. Because they are unique. Let's take our code from above. The segments can go at the top. And let's do part 2. We no longer need to count the special numbers. Instead we will call our deduct function with the observations. Okay, so the general idea is to, let's go back up top. The general idea is to check the difference between sets. For example, if we have the 3 wires of 7 and the 2 wires of 1, then we can uniquely identify the top wire, because that will be the one that is included in the 3 long segment, but not in the 2 long segment. So in this example it would be ACF minus CF, and A would be left over, and we would definitely know that A is the top wire. For example, here we have DAB and AB as observed values. The only difference between those two is D, so we know in this example here D is the topmost wire segment. Okay, so let's get the letters involved in one. So we want to check the length of the entry, and we can check if it's 2, then it will be and we will do this for all observations. We will only select the entry if it has length 2. This will be a list with only one entry, so we can select it like this. And now we do the same for 4, 7, and 8. With the length 4, 3, and 7. And then we can group the observations with length 5, that are the numbers 2, 3, and 5. If you look at them, they all have 5 activated segments. Again, copy and paste. Length 5. And the only one left are the observations with length 6, which are the numbers 6, 9, and 0. They all have exactly one unactivated segment. Now I've already told you that we can find the wire A, the topmost, by taking the wire that is in 7, but not in 1. So, real to fake of A will be the wire in observation 7, where the wire is not in observation 1. And that will only be 1, so we can select it directly. And now we can find wire D, which is the middle one. That is the common one for all entries with length 5, because the 2 and the 3 and the 5, they only share the D with the 4. Find by taking the wire from 4 that is in all observations with length 5. So this one is a bit weird. I've just did some testing here. So if you look at this, then you take you can identify B, which is the left here, and you can only take the ones that we already discovered. So you deduct the 1 from it, and then you only are left with B and D, and then you just subtract the D part that we all just discovered in the previous step. You can remove that, and then you know, okay, the one that's left over has to be B. So for that, you have to take all of the entries here. That's what I did with the set, and then you use the union, which is the combination of the C and F, and then the fake D, which we just discovered. So we have to translate that. So we take the C and F and we combine it with the fake D, and you have to make a set out of it. So you can use union, and then you can use the minus operator of sets to get the one that is left over. And then to take 1 out of a set, you can use pop instead of this notation here. You can see I was getting quite creative. There are now only 2 left over. They are not as easy to get. So I decided to count in how many numbers they appear, which brings me to, again, selecting all the observations. Where these mystery wires appear. I think you can write this a bit nicer. Probably don't have to make 2 lists comprehensions. But now we get E, which will be the first mystery wire. If mystery wire counts, the first entry is exactly 4, and otherwise it will be the other mystery because we want to translate the fake to real numbers to make it a bit easier. Let's reverse the dictionary. So we want a fake to real wires. You can reverse a dictionary according to Google by doing value and key for key and value in real to fake bias. So normally you have a key value pair and you select them like this, and then you swap them VK instead of KV. When I googled this, I didn't find the function to reverse the dictionary, which seems weird to me, but it is what it is. So we deduct this dictionary from our observations, and then we want to translate the signal. Given we have a letter and our dictionary, then we will construct a new string by going through all of the letters and translating each letter with our dictionary. But now we also need to map the signal to the actual number. So first, let's join all of the letters back together in a unique way, so we sort them, so it will always be A at the start, so it won't be FC for 1, for example. Instead it will always be CF because it will be sorted by alphabet. And then we can construct the signal mapping, which will map CF to 1 and a CDEG to 2. So because we get 4 numbers, we first need to concatenate them before we add those. So to do that more easily, we will create those as strings and then we can concatenate them. And A, C, D, F, G. I will definitely make a typo here somewhere. So this is just basically looking at the diagram. And seeing how the numbers are constructed. ACF 7, CDFG will be 8, ABCDFG without E will be 9, will be 0. And now we can use this mapping to return the mapped one of the sorted signal. Now back in the main part we can translate the output. By using signal to number on the translated signal of each output using our dictionary. For each output in the outputs, and now we concatenating all of our translated outputs, transforming them into a number. And then we can use the output sum. So let's see part 2. Example txt. Oh no, of course that's not correct. 6 segments, it's not defined. I had a typo somewhere. Oh, copy paste. Right. Let's try this again. More typos. Not enough values to unpack. I forgot the items. Okay, so it tells us the example will be 61,229, which is correct. So now we can do it for the puzzle input as well. And that is 1,020,159. Which is correct, and we have completed day 8. Please place your bets if I will make it to 25 before the next advent of code starts in December. Also, I would be super interested to know if there is any of you who have seen all of the advent of code videos on my channel. Please let me know in the comments. The code will of course be on GitHub again. If you struggle to follow along, it's really a lot of combinations and you just have to draw the numbers down and do a bit of thinking about it. It's just trying different things and it's like a little puzzle really. I couldn't go through all of the thought process. I really sat down with my iPad and drew everything on, and yeah, most of the thinking already happened before writing it. The only thing you did in code was figure out how to do unions and stuff, but I promise the next one, I don't actually know what the next one will be, but I think the next one will be more coding related and less thinking ahead. But that's kind of the beauty of coding, that you also have to just think through the problem in general and not just write code. Otherwise it would probably get a bit lame after you already know how to code. Those challenges around it really make it more interesting in my opinion. But yes, let me know if you enjoy it. Let me know if you think I'll finish the challenge this year. And thank you so much for watching, and I'll see you in the next one. Bye!